As we all know, I am Jessica Garron from the University of Alaska Fairbanks, and I'm going to talk today about some of the tools that we're using for climate adaptation planning here in Alaska. But before I do that, I would like to acknowledge that my home and my office are located on the traditional and unceded lands of the Lower Tanana people in an area we now know as Fairbanks. My partners in the work that I'm going to be describing today are here on this screen, and it's a diverse set of university, federal, and tribal partners. And I'm going to be talking about observational tools and predictive tools. And I'm going to go pretty quickly because I know we're all kind of sleepy. And most of my observational tool discussion is going to be based around a story I'm going to tell that we've been working on for the last few years. But overarching, remote sensing is just when you use anything else other than your direct senses to sense the environment. My phone is a remote sensing tool. And in this case, I'm going to be highlighting our observational remote sensing tools that we use in the air, specifically drones. But these remote sensing tools, these observational tools, can be used for time series data, change detection, elevation, very critically, real estate delineation, infrastructure inspection, planning, emergency response. So how are we using these predictive tools? Like I mentioned, our airborne tools are drones, airplanes, satellites, and webcams that are statically mounted. I've got a movie here I'm not going to show, but it's not just flying the aircraft, it's creating 2D and 3D maps that we can use for decision making in communities, in agency, and in academia. The primary way that we use these tools is by measuring different components of the electromagnetic spectrum. And my favorite parts of the electromagnetic spectrum are from the ultraviolet up to the microwave. But most of the drones that I've been working on with community partners and agency partners work in this visible and infrared range. Most of the commercial off-the-shelf aircraft have the capacity for plug and play, electro-optical, which is RGB, infrared, and multispectral imagery. And there are now some plug and play LiDARs. But I specifically work with commercial off-the-shelf platforms so that I can learn how to use them and teach other people how to use them so that they can perform self-determination decision-making. So some of the ways that the data looks different can be seen here. On the left, we have a satellite image of the community of Gulliver. Oh, excuse me, that's not Gulliver. Satellite image post-Murbach from the Planet satellite. This is an aerial image from the US Coast Guard. And this is a drone image from our drone team. What I was truly trying to highlight here is the level of resolution available by using drone imagery. This is a change detection map made by fusing drone imagery and satellite imagery of Gulliver post-Typhoon Murbach last fall. Our friend Ben Jones took the drone data that had been provided to the Emergency Operations Center by our team and fused it with this Planet data to create this change detection map. This is not representing entirely the erosion that happened during Murbach, but is a representation of both erosion and NDVI changes to the landscape, meaning stuff which was once vegetated is now barren. As part of all of this effort, I was reached out back in 2018. I got a phone call from a guy named John Henry in Unalakleet. Unalakleet's been coming up a lot. And he had successfully acquired a BIA Tribal Resilience Management and Planning grant. And he was very interested in using LiDAR to measure climate change. And I immediately was like, not LiDAR, not LiDAR. Let's do anything other than LiDAR. And so we stepped it back and did a feasibility study on whether or not using drones to monitor climate change was actually a feasible thing to do in rural Alaska. And so we chose 9 different scientific study areas and performed several different analyses throughout our project, trying to figure out if this was a good thing to do. Of the critical components, not only the science, but we compared different costs of commercial off-the-shelf aircraft and software We performed stakeholder surveys. We did an economic analysis of the different sizes of drone programs, regional, local, or hybrid therein, and also compared the already existing online tool sets and whether or not you could do planning with those alone. And then how did this apply to community decision making? As part of that, we really tried to hone in on the critical plans that tribes are using for adaptation planning. Hazard mitigation plans, economic development plans, small community emergency response plans, transportation, housing, natural resources. Notice the top three, or excuse me, the top two of the top three have to do with hazards and emergencies. And as I said a couple of days ago, climate change is increasingly becoming an active emergency. What we found in that study was that, yes, it was economically feasible, it was scientifically feasible, it was workforce development, and it wasn't just the communities that wanted it. Department of Homeland Security wanted it because they were just as concerned about all the same things that the tribes were. So then we reached out to DHS and asked them to help us train a tribe how to fly. And so we were successful in getting funded, and we developed a community drone team in Unalakleet and co-produced a whole set of standard operating procedures, did a much larger feasibility assessment, and then have been disseminating those lessons throughout the state. Folks were trained on USA-made aircraft. They were trained to collect 2D and 3D surveys and to process those data in the cloud. They were trained to fly legally through Part 107 with the FAA, and they were trained to deliver those products to the Emergency Operations Center in case of the state Emergency Operations Center that gets stood up if there is a major emergency. Some of the high-res observations that they've been able to practice making had to do with oil spill, change detection, freeze up, and then the mapping of those different components. But something that was really important to John, really important to you, and really important to me had to do with pipeline monitoring because of the unstable permafrost and potential oil spills as a result of bulk fuel containers going into the water and broken pipes. So we've spent a lot of time over the last few years trying to monitor pipes using UAVs, whether it's methane, electro-optical, infrared, lots of different signatures. We've also been practicing those infrastructure inspections out in the communities. This is just a change detection map of the water pump house in Unalakleet. And then when one is not going to go ahead and go all in and create a 2D orthomosaic, my pilots are practicing with taking a synoptic view. If you only have one hit before your drone comes down because it's too windy, how do you make that the most useful you possibly can? So, we add little tricks to trade synoptic view. In a lot of cases, communities are happy with just a snapshot. But the other benefit of these tools is that we can do repeat flights, the exact same spot, the exact same time. And then we can create these 2D and 3D models. This was actually a 2D digital elevation model that was completed by one of the team members post-Merbach. This is actually Hooper Bay. We provided all of the imagery that we collected post-Merbach to the communities directly via text message as a PDF or a JPEG because they don't have GIS technicians, and then also to the Emergency Operations Center. And what was shocking to us was that when talking with our partners in Hooper, like, oh my gosh, we had no idea how low we were until we actually saw the map. We also do the 3D mapping, and this is specifically for infrastructure inspection, so we can really, get the nuanced details. So it's just a program. It's not hard to actually physically do. And then it takes all of the photos from all of these different angles, compiles them into a 3D model, which is really awesome if you're trying to perform inspections on dangerous or unsafe infrastructure. Pairing those drone data or other observational data with what I would call ground truth data, extreme gauge data, carrying satellite imagery to drone data. All of these are part of the observational process. I alluded to flying during Merbach. So we trained all these folks under a DHS grant. And then we've been working on contracting so that the native village of Unalakleet can be directly contracted by Coast Guard. And it's on the Coast Guard problem side of the house. But what has happened in the last summer was Unalakleet was subcontracted by the U.S. Coast Guard to fly geographic response strategies throughout the Norton Sound. 2 weeks after that, Merbach hit. And that's when we recontracted everybody again. And the pilots from Unalakleet and from Bethel then performed the post-storm assessments. And this also is of Hooper Bay. And this is while we're out there having a heck of a good time on a heck of a bad day. But moving on from observational case study work, workforce development, and capacity building with hands-on tools, I'd like to talk a little bit more about the Climate Adaptation Science Center and the planning tool sets that we have been working on there for many more years than I have been there. So the Climate Adaptation Science Center is a partnership between universities and USGS, and specifically focusing on the science around climate adaptation. At our CASC, we really are focusing and leaning in on the concepts of co-production, developing questions and solutions together with all of the people at the table, with all of the concerns, not just stakeholders, rights holders. The Climate Adaptation Science Center is home of the Alaska Tribal Resilience Learning Network. Melinda is the lead of the Alaska Tribal Resilience Learning Network. This is I'm going to have Melinda describe it to you separately so she can give you the full description. But essentially, it is a network of tribes learning from each other different adaptation possibilities, as well as asking questions together and learning from each other and learning from the CASC. So the science that we do at the CASC is primarily modeling and capacity building, whether it's climate, glacier outbursts, landscape change. And just to put us in context, we're one of 9. They're proposing a 10th, but we partner a lot with our Pacific Islands partners because just like everything, we actually have quite a bit in common with those folks. But one of the main efforts that I alluded to is that we are really, really trying to institutionalized knowledge co-production. Not all science questions are co-production science. I would say, like, digging a borehole may not be co-production science until I went to Point Lay and Bill was saying, oh, there's Dimitri's borehole and all of his sensors and whatnot. I was like, wow, that he just proved baseline science could be co-production. So I need to read that one a little bit. But it's all to, build capacity among the entire team and move our society forward together. Some of the specific climate tools or climate models that our team at the Climate Adaptation Science Center has produced have then been visualized as online climate tools that are accessible for everyone with an internet connection. And those climate tools provide historically downscaled data, projected downscaled data for Alaska, and derived products for the Arctic region. But just having it online is actually not enough. So there is a major effort led primarily by Melinda's group to integrate these planning and adaptation tools into tribal planning and adaptation and into the managed, the relocation, manage in place, or managed retreat discussion. And what we are trying to do with what could be considered highly complex model data is make it accessible for all of us Alaskans. It's a very powerful tool set, being able to click on an icon and get full-on model projections. So I have skipped from the Climate Adaptation Science Center into the Scenarios Network for Alaskan and Arctic Planning. SNAP and CASC are joined much more closely than the HIP. SNAP does our visualizations. task does the modeling. This is all for a simplification of the concept. But we offer at SNAP an entire set of climate tools, some more nuanced than others, but some that are absolutely fabulous for. And the Arctic EDS is what Kevin was talking about at the end of his talk, modernizing the Environmental Atlas of Alaska, where all engineering, the engineering Bible, if you will, for construction standards. So using the model data, an integrated ecosystem model, climate change models, and several other model outputs, we have made the SNAP team has made this tool so that we can access all of those data in simple clicks. And this is what the interface looks like for Arctic EDS. It's still in beta form. The way this data is organized is engineer speak. This is not normal people speak. I have not ever gone into a village and had somebody say, could you give me a visualization of freezing index? So this is really what Kevin was saying, is a tool for the engineers. This does not replace engineers, just saying. This is a starting point for planning. This is not the end point for planning.
2 minutes, Jessica.
Perfect. So the output of Arctic EDS is fairly straightforward. I really like that a lot because I grew up as a scientist, and so I'm good with like black and white outputs and whatnot. But the same database drives Northern Climate Reports. Now, Northern Climate Reports is very similar data, but is a different format entirely for quote normal people, non-engineers, to understand. The same type of data is presented in a narrative, as well as different types of visualizations. As I said, it's driven off the same data set. So I just pulled up the last slide was Arctic EDS for this area, and this is Northern Climate Reports for this area. And we have a snapshot of what the permafrost could very well look like in the very near future, according to our climate models. But like I said, I'm a knowledge broker. And it's not just flying drones and using model predictions. It's teaching neighbors. So these guys, these coasties, they come and they go, they haul boom, but they're the ones that are going to be here to help during emergencies. The Coast Guard are responders for oil spills, are responders for major coastal disasters. FEMA and the Red Cross will get there, but Coast Guard plays a big role in our state. But they're only here 2 years. And so, you know, I get these young guys, they come out flying with me, and they fall madly in love with everything. And I'm like, well, but it's all permafrost. It's all going to be different the next time you come back when you're an admiral. Like, what do you mean? And I don't travel with a frost probe. So anyway, this was something last summer. We were on a mission with Coast Guard, and we were out in Nome, and there was this construction site, because like I said, I don't have a frost probe anymore in my grip. And so I get this like big honking piece of metal. I'm like, I need something hard. I need something long. And so I get this coastie to, you know, go dumpster diving for me. And we go out on the tundra. This is just behind the new hospital. And I taught him how to frost probe. He's like, wow, it's wicked hard. And then I'm like, oh, wait, no, but I've got to feel it. So reaching down in there and like touching the ice, running his hand along the ice, and then pulling it out, showing him what organic matter versus silt looks like. So this is critical outreach. This is not anything in any book, but this guy, he's going to go up the ladder, and someday he's going to be head of PAC area, and they're going to be making decisions about what's going on up north as well. And it's all about the team. It's not a one-person thing. Co-production takes a whole lot of people, takes a lot of diversity in backgrounds and skill sets and drive. And so this is just some of the team during some of the good times that we've been having together, using these climate adaptation tools for emergency response, for planning, for infrastructure inspection, and to monitor different climate change scenarios. And again, the team, Thank you.